Hi everyone, this is Eloth. Welcome to this fourth and last video of for the Gauntlet, the Foundry Gauntlet Revision 1. Today we'll try to make the last stage a naive implementation of the last stage. This video is a little bit less early than the previous ones. And it will be only gameplay. I won't give you too much tips, but if you want to follow along with me, this video is for you. So without further ado, let's jump into the last stage, the 4x8-bit delatches memory bank. And before that, I will just pick the URL for the bests of this week. Even though I won't use it, I will just show it once more how you can just simply copy the image link and then paste it into the game to have the delatch. So this is exactly as the previous week. We use mostly the same entries, inputs, and we will reuse the week 2, the delatch cell 2x2, and we just put that in an array of 8, so we can have a memory bank of 4 addresses of 8 bits. So there is a lot of text. I hope you guys are reading it. It's just give a little bit of insights of this is really just a basic memory bank. It has its own limitation, but it is a really good exercise to know and how to play with those type of memory bank, at least within a chip, because I think this won't be the last type of memory bank we are doing. I will just close that, and I think I will keep that maybe there for a while. Yes. First thing, I want to show something really simple. You can use import from clipboard for a lot of links that are compatible with HC. You don't need to use the library, it's just that you will just use it one time. And for now, this option doesn't import the labels, so it can be hard to know the pinout of this part of the circuit. And I was on, like I was telling earlier, I will not use that. So let's go see every 2x2 I have. So I already have the winner from last week, which is this one. So you see, if you install through the library, you will get those labels added, so it's much easier to find what you need to plug. But I want to do a huge chip because it's also what this gauntlet is about. It's about making something really big and how we can achieve to do that without too much trouble. And so I will use my subprocessory submission for week 2, which is this one, I think. Yes. So let's go with that. But first, I want to take a look at the leaderboard, because we have our 8 survivor thank you so much for playing the gauntlet to this point. It means a lot to me, so thank you a lot. I think we have mostly during the week less active submissions, but maybe last 24 hours will be more active. Maybe Silly Mail will do something, I don't know. Mysterious Architect is on the top. It's hard to get past him, but if someone wants to try, I will just be really happy to see him challenged a bit. And do keep in mind that the Gauntlet leaderboard is never selected automatically, but you still have those to keep a look for, because remember, the rewards are for the top 5 players. The reward is the Gauntlet team, and I will activate it so you can see what it looks like. And for the top 3, it will be Chip Steam keys for your friends. So do keep in mind this leaderboard as well. So let's go here. I will just change my team so we cannot do that from the editor itself. What I can do here. There we go. So this is a dark team, red-ish kind of. I think it is cool, but you know, taste and colors. Let's go into it. 2x2, my sub, and I will use a lot the mirror feature. Let's go with that. I will just go like this. So maybe it won't work for the end of this video. I will try not to make a video too long, so we'll keep an eye on the time. So we have our basic first cell. I just want to make sure that we have something that is plugged correctly. So I should be able to write the first byte of the 8-bit word into that cell with just the tests. They won't work, but I can just do that. And then the output should be this, and I was right, so it must have been that. So my old blueprint doesn't have the label. I will work on that to make sure that we have something interesting with the labels, but it seems like those are still too big. Even when we paste the blueprints, they are quite big, so I need to think about something that is small that we can like spread out, because if you, for example, take a blueprint with the labels, you do this, and then you have like this whole mess of blueprint labels that overlap each other. And even though you can just select everything like so and use that little options, remove probes, it kind of feels cumbersome, so I still need to find a good recipe for these parts. But I wanted to check writing the first, so init, we write, we stabilized, I clear the flag, and then we read. And it doesn't work. So what I did wrong? Right. Ah. Okay. Am I plugged in correctly? I should be. You know what? I will just take a look to be sure I'm writing down that properly. So this should be. So this is enable write and okay. Just making sure this one. Oh, okay, so it should work. Let's go back. Okay, so this is in the wrong order. Enable write. I will activate this. Oh, okay. I think I got, so I want this. So you should have written 1 in one of those cells. So this is this cell over there. And if I turn to neutral this one, so you'll see this is a new video, but you can click to cycle through 0 and 1, but if you hold control, you will go back to neutral. Also, you can go there and use the neutral not allowed or allowed, and you would not have to press control to cycle through neutral. Oh, okay. So I didn't know what I got wrong first time, but okay. Let's try to move on with that big monster. So what I have in mind is like not especially using this layout. I think I will not follow what I put, but I will maybe make a big row of. Oh no, I will follow this blueprint because I don't want to mess too much with the lines are already placed. So I'll go with that. So firstly, we want to have like 2 bytes. And then I will flip this one on the x-axis. So we'll have a bus of 4 bytes grouped together. And I will do the same a second time to have the 8 bytes. So let's try this. I will reduce the die size to its minimum. So we have a good starting point. The mirror mode will change a bit because right now it's just this all die duplication tool. But it's not really practical because if you want to introduce some stuff that are not symmetrical, you can have to not use the mirror because you need to do those slight differences between copies. But for now we have that, so let's go with this, and I'll take just 2 by 2. We can make it, let's make it big first try. So I want to copy on the right, and I want to flip on the X, it's on the Z axis, flip. Just I want to make sure I'm not wrong. So it would look like that. So yes, and then another copy, and then another flip on the Z axis. And because I need to have a 4 bus wide, I will just add another row for my bus, and of course we need to extend those lines. So this is power, I think this is the address for the column, the write, and the enable. And it's slightly the same here because I already did a copy of that, but I'm not making something efficient here. I just want to have something maybe that will run. And this is the one. And so we want the second one to write on the second lines of the bus. So we'll try with that. Mirror mode. I need to activate the overlap mode to have the shared, because if I do that, you will see that little space between blueprints, between the bases. I think something is maybe not efficient here. I don't want to connect. Let's just verify this. Yeah, no, let's not connect these. Even though I totally could. Can I? No. So you see I already forgot where everything is. I'm trying to keep a beginner's eyes on those levels, because I prefer to spend the time developing the game instead of playing in it. Let's go with that. Let's see if we can. We have already some issues here. We need to connect those. So we need to connect here, if I'm not mistaken. Okay. This one, no, it's the byte from the bus. This is our 0 constant. Oh, let's connect it here. Won't connect to anything else, but that's all right. Okay, let's try this. And I need to activate the overlap. We might have some issues still. Yes. So to make sure my cells are not sharing anything, I will remove it. Even though I might need it still, because this is you can see the pattern from the 4 delatch cells, and then in front you have those 2 inverters that are needed to make the 2-bit address decoder. So my options here is to just share those 2, but you know what? We are not here for optimization. I'm here for triggering my player. So we'll go this route, and for this one I need to bring that line, so we'll just do that so I can select everything without thinking too much about it. So this is our, no, which one is it? Okay, so this is our address line, and I will go like this. Like this should be, no, I need to go up 2, and I would need to go this way, but I don't want to connect to that thing. I can do something really simple. Up. And here we go. Not sure where I need to end to, but those tame they are really close. So I could be, and I will be lazy. I will just expand this, so I don't need to think too much about it. Let's go this way, and then we apply. And so now I can just I need to connect those 2. Let's make sure I'm capturing the cursor as well. Okay, much better. So I can do this and this. So I just need to do that. And on row 9, I need to connect. So 9, it's here. I just need to do that. Okay, let's try that. Yes. Am I selecting too much? Yes, I think. Yes, I'm selecting too much. I'm connecting to that one. Obviously. So this is this way. Okay. Great. Okay, and this should be connected there. And it's not. So I don't need this. So either I just need to do that, so that it's fine. I don't need that. Okay, let's try. Of course, I extended a bit the die. So this is our power. And what else do I need? I need this, this, and this. Okay, let's try again. So now we should be in business for... okay. We'll just do that. So we can share the power. Okay, everything's empowered. That looks fine. Now I need to watch for the address. So address 0. Did I click on this? So I want the entire line to be selected. Okay. That looks great. Everything seems connected. Great. They are reversed and they are connected properly. Well, okay. So we have our columns. So if I do that with address 1, which is this one, I should have this connected to the entire set. And somehow I need to send this signal to the bottom. So what I'm doing with, so this is right and another one right. Can we pass something else in there? Maybe I can just use of space here. Oof, that would be tight. I'm not sure we can. Yeah, I think my best bet is this way. So I need to have some space here, because I will collide with something if I'm not careful. So as see the time goes, I will just go crazy lazy up. We will do something with those. Okay. Let's verify that we still have power. This is nice. We still have this going through the entire chip, so this is fine. And so we need to send this on the bottom. So yeah, it took some time to... Yes, you need to do that then, not after the duplication. And we'll send that one over there. And we need to have 2 space, otherwise they will collide. And because we have more than just those 2, we'll have in fact to do a monster like this. Let's go for that. Okay. So now if I select this, yes. I'm connected everywhere. I have no idea if my chip will work, because I'm going a bit without a plan here. But we have now our address line. Let's take a look now our out right, which is enable. So it goes there, and we need to take our right from that line. Okay. So I guess I can just do something like this and this. So I will extend this a bit, go down, just reapply quickly to make sure I'm not touching anything. On row 22 we need to go there, so let's do that. We need to connect to this. Up. Let's go 22, and I will do the same then for... It should connect to everywhere, to everything now. Oh, I could have used that. Too late. And right now, just need to be sure that still enable is shared across. So we need a tiny connection there. Okay. And I should connect to nothing. Great. Just verifying. So enable is now across our chip. Great. And now this right line, what can we do with it? I'm sure we can connect easily. Oh, there is quite the wall here. So I think I can maybe squeeze. No, I can't. That's annoying. Where do I need to go from there? Will I? Oh, I'll do that thing, I think. So we are row 35. So I'll just lazily go there, there. Let's go with that. And for it to share with the neighbor, it's already made via this connection. And now I need to think about the lower quarter of the chip. So if I select this, the lower half, obviously. So we need to think about a path around here. So I think I will just use that space right here. Can I make something work? I would just do a test. So I should need them to do that. It's a tight fit. You shouldn't do that. Okay, so that should work. Let's do that. Okay, so I want to use that space for our right. So I should do that. This needs to be extended one this direction, and then let's go this way. And then with that, we should be able to have our right. I'm not really sure what I'm doing, but I think it should work. Okay, so we have something that works. So now I don't want to use that because we have two buses of 4 bytes, right? So I need to send those bytes the other direction. So what I want to do is two-step mirror operation. So firstly, I want to reduce that to this. So I have one functioning rows of one functioning bus. Let's make sure we are still in business with our connections and wiring. Let's go. So I'm committing to this. So power up. Now we write the 4 bits, and it will be the lower bits. So I should have 0101 when I read back the sales value. And I got nothing. So what did I do wrong? Obviously, I know I didn't plug the so I need to plug the bus. We might have a bug. Okay, we'll just exit and reload. With a little bit of luck, I didn't break everything. So I did break that. Okay, and then I needed to redo this, copy MZ with overlap. And so my issue was I was plugging everything onto the same bus position, so you see everything is connected to the same. So this first group of 4 delatch will take the first line, the second one will take the second, and we'll just mirror that the other way around. And so the bottom is already plugged properly. And so now if I do this, up, great, so power up. Now we can go forward with the validation because we are lacking the 4 bits, but I can select manually. We'll do our clear. So we should have one of those cells that are written into. So you can see those 3 are not properly set. They are still neutral, but this one is definitely holds a value. So if I do that, I should be able to get something. And I don't. So what I'm doing wrong here? This. Do my right is good. Should be okay. Oh, it seems that I forgot something here. So I just have to make sure. Let's go with that. So if you have a proper planning, this shouldn't happen, obviously. But I'm doing it live and I want to finish that video fast, and I think it's not a good idea. Right. And obviously I need to redo my pinouts. Let's go with that. So I want the right, I want the clear, and I want to read back from those values. And obviously I need to redo the pinouts. So those 2 need to be there. And we had a shot, so this is really a good sign. Voila. The right. Now we clear the flags, and then we read. Yay! Woo! Finally. So we have our 4 bytes, least significant bytes set. So now we can use that as a base to redo another mirror operation. So we'll do a little bit of cleanup. So we don't need this because we are connected differently. And I don't remember how I shared that. Ah, yes, through this little point, so it should be fine. This, we don't need it as well. And obviously this should be fine. Yes, so I can remove that. And this is connected. Enable. Yeah, it's there. So this useless as well. Making minor optimization, but you know, I need some space to make sure everything goes through properly here. So what I will do is quite simple. I will just use this like that, and 2 like this, and it will connect to the corresponding 4 bytes on the other side, like so. And I need this on the other side because I need to feed back those value here. So I think I will need to expand one more, and I'll make it to 2 because I want to finish faster. And I will just align those like so. Yes. So now if I do this, up and up, we should have a base that should work. So now I just need to make 1 by 2 and MZ operation. So now if I turn one of the upper bytes on with the block that are set, I remove those blocks every time I do a mirror operation, but it's obviously not a good idea. And I need to extend a tad bit up. So I'll go, I need to cut like so. I'll just take a section and I'll patch those little ones. Why this one is selected? It shouldn't. Do I connect to something else? Obviously, yes. This is not the proper. I can just do. Up. No. Okay. Still, it was connecting to the high byte. What it was doing? Where is coming back from? What is happening? So this is properly connected, but why do we share this line? Because it should fail here as well. Yes. Let's be lazy. I will just cut through that line. So this is the byte we want to connect to. So I don't know why I put my initial template with this connecting through, because we can just remove that entirely. And it should be working, but I won't do that too for the sake of time. So I will just cut those lines. And now it's okay. And if I select the other byte, yay. I think we are ready for a test. So this is quite the monster I just made. There is a lot of inefficiencies. As you saw, the base templates need a lot of refinement, and even then you can have a way more compact solution. But let's try with this. Should it work? So this is the console dev. I want the Zen view, so you can press F8 to have that. Let's see how it works. Our phase, clear, write, and first read. And I have everything but one byte. This is really encouraging. But why did I broke here? Oh, this. I was a little bit too enthusiastic with my delete. Let's try again. Fate. Yes. So first read passed through. We are writing the second. Second read is okay. Clear. Write second address. Third address. Read back from it. Cool. And fast 3, same thing for address 3. Okay, all addresses are working. We are just verifying now that we didn't correct other addresses during the test we just made. So we should have those same values. So it went through. Great. And now we redo the same with different values, but we won't read back from it. We'll just verify after the fact. So I'm rewriting everything. This is a monster I just made. It's hilarious. And 3, 2, go! And then now we have our random phase, which will just rerun few of those phases. You can activate that in the CSE if you are on the experimental branch, and it looks like it will go through. So with that, this is an incredibly long video of 54 minutes, but you had like this session of a typical first try naive solution for the subprocess submission for the gauntlet. And with that, I will stop the video there. Thank you a lot for following this long with me, and I hope we'll see each other on the leaderboard. Bye!